So we'll install a heat pump to generate that 4 kilowatt hours a day, backup immersion heater. Now what's happened is over the last 9-10 years, 4 out of the 5 heat pumps have gone wrong for one reason or another. We had this chap in a white van running up from London to fix them. I thought that's not looking very good. Over that time we've ditched 4 of them. One's still working. The other 4 have stopped. So slight concern there over length of time and cost, because they're quite expensive bits of kit, and perhaps should have been more reliable. But I think one of the issues is when you're taking heat out of air, that's the evaporator there, you have a tendency to cool the air, and the moisture in the air can freeze. And then you have ice build up on here. And so you've got things freezing and defrosting. You've got a high pressure pump. You've got the refrigerant gas running around. So if the plumber who takes it out accidentally undoes the wrong pipe, you then release very potent greenhouse gas into the atmosphere. And that's hardly ever mentioned, but even the good refrigerant gases are 3,000 times worse than CO2. So there's a real potential for causing problems when they're decommissioned. So what we've done, we've not replaced the heat pumps. We've used the backup immersion heater and running it from our wind turbine and photovoltaic panels, in essence. And there's one big advantage of doing this, is first of all, and we've kept the super insulated tank. That's the key bit. But the big advantage of doing this is that this costs 20 quid, whereas this is several thousands of pounds. That's it, really. Okay, so solar tool, we have some renewable energy device on the office, so we heat water in the office with a more traditional solar thermal panel. So this is a solar twin system, so collecting the sunshine, heating up water, taking that water inside into the water tank. I like the system because it's got this little panel here, which you can just see, which is a photovoltaic panel, which drives the pump. A lot of solar thermal systems use mains electricity to run an AC pump to pump the water from the panel to the hot tank. And that is very inefficient because grid electricity is 0.4 tonnes a kilowatt hour CO2 released, and AC pumps are inefficient and they're not. So the overall system efficiency can go right down if you use the mains to pump. This uses a little photovoltaic panel to drive the pump, has 2 big advantages. One, it's using the sunshine to make the energy, which is brilliant, and 2, it works when the sun comes out automatically. And when the sun comes out, that's when you're getting hot water in the panel. So it only pumps when the panel's hot because of the sunshine. So that's quite a clever, neat system. And of course it means there's no antifreeze in this. It's it doesn't mean that. The system doesn't have antifreeze in it. They've designed the pipe work in the panel to be able to cope with frozen water. Which is really good because it simplifies the system, the plumbing on the inside. Makes the plumbing much easier. So, money spent and CO2 saved. Solar hot water, these are figures from a book I picked up, but pounds spent versus tonnes of CO2 saved. Solar hot water system, you might be spending 557 quid for every tonne of CO2. PV will be less than that. Wind will be less than that again, and then adding lots of loft insulation, if you haven't got any, is so much better. That's just, as ever, emphasising the fact that if you're going to spend your money, spend £5 on loft insulation and save the tonne. Don't go out and buy a wind turbine. But if you've done that, and then you're thinking about what to do, wind turbine first, then PVs. Last of all, solar hot water heating. Renewable energy summary. So this is a table of our photovoltaic panel capacity here. So 7.6 kilowatts of PV. Total cost £40,000, expensive. So total cost of Proven 26, total cost of ISCRA 23. Production figures there. If you divide the production by the rating, you get 653. And this is just a useful rule of thumb to work out, how much installed capacity you need. Because our systems are producing about 650, 692, 780, sort of in that range of electricity produced per kilowatt of installed capacity. So if your house uses 654 kilowatt hours a year, you know you just have to install 1 kilowatt of installed capacity of PV. Simple rule of thumb. It's not very accurate, but it does give you a starting block. Predicted output for the turbines, for the programme, the manufacturers said 11,000 kilowatt hours a year. The ISCRA 12,000 and the PV was predicted to produce 6. The actual outputs have been more like 4, 4 and 5. So beware manufacturers overemphasising what their kit can produce. The reason we think is because our actual wind speed is much less than the predicted wind speed. So obviously again wind speed is more important than anything else with wind turbines. The photovoltaics is actually closer than probably the wind turbines and is easier to predict, to be honest. So lessons learned, wind speed is inconsistent over the year-to-year periods as well as day-to-day and might be inconsistent with predicted. Height is important, so if you're going to put a wind turbine up, put it high. Manufacturers' estimated production figures may be high for PV and wind and heat pumps. We consider the energy production as part of the house, not as a business expenditure. So the families didn't buy it to make money, they bought it to produce renewable energy. So although those turbines don't produce as much as the manufacturer predicted, we're not really too fussed because they're producing what we consume, more or less, which is our target. Obviously it would be better if they produce more, but we're happy because we're producing what we consume. The feed-in tariffs will definitely make a difference. They are going to up the ante loads, I think, because they're quite significant. Okay, so that is the end of that little presentation on Hockerton Renewable.